Welcome to the last two sections of our chapter. In this lesson, we're going to look at 2.6 and 2.7, where we look at inequalities. We also talk a lot about different types of notation, which will come up often throughout the rest of the semester, and just some word problems that go along with that. So, in order to determine which direction our inequalities go, let's just go through the basics. So less than looks like this. Less than or equal to looks like this. Greater than goes the other way. And I feel like we already did one of these because I remember mentioning the alligator mouth opening to the bigger side. So number one, determine if x is a solution. So we're going to plug 6 into x. So 3 times 6 plus 2. Is that less than 20? That is the question. And so 3 times 6 is 18. 18 plus 2 is 20. Is 20 less than itself? No, it is not a solution. If, big if, this was like this, then the answer would be yes. But since there isn't that little red line right there, then the answer is no. All right, let's practice graphing a little bit. And then we go straight down here to both set builder and interval notation. So when we graph, it is not just a single number, it is a range, and often it is an infinite. It will go on forever and ever and ever, either to the left or the right. So in this case, this is saying x is greater than or equal to 2. And as a general rule, if your variable is on the left, then the inequality points in the right direction. So it points in the direction that the graph is going to go. All right, that will switch if your variable is on the other side. That doesn't necessarily hold true. But x is on the left here, and so it equals 2. So we have a bracket. Back in the day, you might remember it as a closed circle situation, or a hard bracket like this. And then we're going to move to the right. So it's all of these numbers here. So that is a hard bracket there, and then goes to the right indefinitely. Here we are between -4 and 1. It looks like we include the 1, but we do not include the -4. So when we don't include something, you might remember the open circle. Now we're going to use parentheses and brackets, and so we're going to have a soft parenthesis here. And then because it includes it, we're going to have a hard bracket with 90-degree angles there. And then x is everything in between. So this is a finite set. Well, not really. It's still an infinite set unless we were talking about integers only in a word problem situation. But it doesn't go to either infinity or negative infinity like the other ones. All right, last example. If this is 0 here, and we go 1, 2, 3. Oh, I guess I meant that to go the other direction. Oh, well. And so then we have a soft parenthesis, and again, we go the direction of that inequality. So we go that direction like that. Let me just throw one on here that is less than only. So if we were going to say, hey, this is less than, I don't know, -1, and we had that at 0, and so this is at -1. Again, a parenthesis we do not include. It is less than only, not less than or equal to. So anytime it doesn't include the number, we're going to do kind of a curve. That's kind of an over-exaggeration there. And then we're going to go to the same direction that the inequality is pointing. So since it's pointing left, we go to the left. All the numbers less than -1. All right, we're going to take these same examples and we're going to rewrite them in two different ways. One as set builder notation, which is not my personal favorite, and two, interval notation, which both are used in college algebra, both are used in pre-calc, and if you have to move up to the calculus level. So set builder, you have these little funky set brackets here. You write this X, you draw this vertical line here, and then where I have in yellow, this is the part right here that's going to be the inequality. You just rewrite the inequality, basically. It's not hard, which is, I guess, why it's not my, it's not hard, I just think it's kind of silly that we have to write it in this fashion. So X such that, and then X is greater than something, X is less than something. So here, if this first example was in set builder notation, it would be X such that X is greater than or equal to 2. If I was going to take this example here and give myself just a little bit more space, I would write example B as X such that it is between -4 and +1. If I was going to write C in set builder notation, I think you probably have the hang of it now. You would write it as X such that X is greater than 3. And if I was going to do my last example here that I kind of squeezed in, it would be X such that X is less than -1. All right, we're going to go through it one more time, and now I'm going to talk about interval notation. So I'll switch colors here so it kind of stands out. Now, interval notation, it's either going to be soft-sided parentheses if it doesn't include the number, or it's going to be brackets if it includes the number. So less than or equal to, greater than or equal to. All right, and if it goes forever, we're going to use the symbol for infinity. Now, interval notation in general, it goes small on the left, comma, biggest number in the interval on the right, and then you're going to wrap it in either parentheses or brackets or one of each. So it's going to be one of these on the left and one of these on the right, depending on the situation. So that in general covers interval notation. I do have a separate video about that from last semester that I can upload to Canvas as well. All right, so let's go back and look at A and write this in interval notation. The smallest number here is 2. 2 has a bracket because it includes that number. So if I was going to put A in interval notation, it would be bracket 2, comma, how big is this thing going to get? It goes off to the right forever. So the biggest number cannot be reached. It goes forever to infinity. So we write infinity here. And since you never can reach infinity, you can always add another 0. You're going to use a parenthesis. Whenever there's an infinity or a negative infinity, you write it as a parenthesis. All right, so here is A in interval notation. If I look at this one in interval notation, if I look at B, this was going to work out much neater in my head. So I'm going to write it down here so it stays on the screen. We are between -4 and +1. And so the smallest number is -4. The biggest number is +1. We are bound on both sides. We include 1, but we do not include -4. All right, I'm going to do D because it goes the other way, just to show you one, and then C works the same way as A, more or less. And so on D, x is less than -1. So we're going to the left. We're getting smaller and smaller and smaller and smaller. So we are going to eventually reach -infinity, but we never can quite get there, comma, the biggest number it's going to be is -1. And since there is no line right here, we do a parenthesis, not a bracket. So that is interval notation. All right, that might be, oh no, and then what I did, and I included this on the PDF, it doesn't have set builder, but it has everything else. So there's kind of a nice little study guide for you. I found that online, so it's hard to kind of see whether they're brackets or parentheses. Hopefully you can tell the difference. Those are parentheses. Anytime there's an underline here, it would be a bracket situation, and so on. So feel free to print that and use that as a study guide. And so now we are going to use those to solve. So solve in each inequality and graph. So our rules more or less stay the same unless we're looking at these examples down here. So solving for x, I think I meant to put that as a plus. So -2x minus 2x. 3x take away 2x is 1x plus 2 less than or equal to 5. Subtract the 2, subtract the 2. So we have x is less than or equal to 3. And then when you do the homework on MyMathLab, you'll write that in set builder, sometimes in interval, and sometimes just being asked to graph it. So here's a little sketch. Here's 0, 1, 2, 3. It's going to be that hard bracket because it includes 3, and then it points the same direction as the graph. And MyMathLab does a really good job of using different colors for that as well. All right, this one is blank because I wanted to throw in a fraction just so that we could practice what to do if we have a fraction situation one more time. So if we have something like this, x over 2 plus 4 is greater than 3. And yes, let's do greater than. Let's take that 4 to the other side first. Subtract 4, subtract 4. X over 2 is greater than -1. Remember the opposite of, not the opposite, what undoes divide is multiply. The inverse of divide is multiply. And so we multiply both sides by 2 to get rid of that division. And we get x is greater than -2. If I want to graph this, here's 0, -1, -2. It does not include -2, so I want to make sure I use a soft parenthesis this time, and it goes to infinity. If you want to try your hand at those, and see if you can write those in interval notation. If I circle back to A, the interval notation here is -infinity to +3 with a bracket. If I write this in interval notation, on the left-hand side I have -2. It's a soft-sided parenthesis. And then I don't reach infinity either, so I have a parenthesis on the right-hand side as well. All right. When you multiply or divide, this is the last kind of thing that you need to know for this section. And it is easy to forget. When you multiply or divide by a negative number in an inequality situation, the inequality switches. It flips. Less than becomes greater than becomes less than. So here's an example of how that works. Let's take that 3 to the other side. That negative 4x comes straight down. 11 take away 3 is 8. We are dividing by a negative number. We are dividing by a negative number. So right here, this inequality is going to flip. And if there was no equal sign before, there's no equal sign now. So if I want to rewrite that in Set Builder, I could rewrite it like this. To practice our interval notation, which never goes away, it would be negative infinity to negative 2. And to graph that inequality, here's 0, here's negative 2, and it goes to the left. And again, as long as your variable is on the left, you're good. So what do we do in a situation like this? Let's say we have x, or 10 is less than or equal to negative 3 halves x. All right, so in this situation, and let's add in something, let's say minus 2. There we go. All right, so now you see that the variable's on the right-hand side. So we've got negatives here, we've got the variable on the right. Everything is kind of a mess, and with inequalities, I really prefer to have the variable, if possible, on the left-hand side for graphing. So I might rewrite this whole thing. So please note right here that this side is bigger. This is the bigger side. The alligator mouth opens to the bigger. So first of all, if I choose to rewrite this, so x is on the left, I'm going to flip that. And now I'm going to solve this exactly like I solved A. Let's add 2 to both sides. Negative 3 halves x is greater than or equal to 12. I'm going to multiply by the reciprocal because we need to divide. How do we divide fractions? We flip it, or we multiply by the reciprocal. Right here I am multiplying by a negative number. So yes, my inequality is going to flip once again. Those cross out, those cross out. I left with just x. And now I'm back to being less than or equal to, and we can put a 1 underneath there. You can go 12 times 2 is 24, divided by 3 is negative 8, or work that out however you choose. You can cross cancel. In Set Builder notation, I'm sure you've got the swing of it. You just kind of put that same exact inequality in these fancy brackets. If we were going to write this in interval notation, we would end up with a hard bracket there. And if we were going to graph it, there's 0. And then 1, 2, 3, 4, 5, 6, 7, 8. Hopefully there will be nothing where you would end up having to hand graph like 26 or 85 or something like that. So that's an advantage of MyMathLab, I suppose. And so let's do a hard bracket like this. And now, because I did that extra step, x is on the left. And so it goes to the left. All right. I think that covers everything. It's always a mystery to me, even though I'm the guy that wrote it, I've already forgot. All right, 2-7, this is it. This is the last one. I just have a few questions. Again, I imported something for you to kind of help you out with some of these application. So if you see is more than, is greater than, and it tells you what sign to use when you see those expressions. So for instance, translate to an inequality. Vanessa's job requires her to have at least 3 years of experience. At least. At least is right here. And so this will be the inequality we use in this problem. So if that's helpful for you, until you get the hang of this, that's great. So how do you write the job? Well, in my math lab, I noticed a few of these. In my math lab, they just assign whatever it is a variable. So like J for job. And so the job requires greater than or equal to 3 years. Oscar knows he has no more than $25. So he could have 25, but he's not going to have 26. No more than goes this way. So you can try this one, even though I already kind of stole the show there. I wouldn't use O for my variable for Oscar, so maybe M for money. It doesn't even have to relate. Less than or equal to 25. Let's do a few word problems here. Okay, it says write and solve. To cater a party, Rosa charges a $50 setup fee plus $15 per person. This type of word problem was also covered in 2.5. I chose not to do it so that it wasn't one more thing. We could cover it right here. Whenever you have a per or an each or an every, it depends on how many people are going to come. So this is known as a variable expense. And this setup fee is usually a one-time. So this happens once, where this piece right here kind of varies depending on the number of people. So this is where the variable is going to go, varies variable. So 15x plus the $50 one-time setup fee. The event cannot exceed 450, so it has to be less than or equal to 450. How many people can attend? So solve the inequality. Subtract the 50. We're going to get 400. 15x is less than or equal to 400. So 400 divided by 15. It has to be less than 26.67. So x is less than or equal to 26.67. You can't really have 7 people, 0.67 people, and so it would need to be x is less than or equal to 26 people. Let's look, you can stop and try the try. It's similar, but not exact. Ron charges $75. There's your one-time fee plus 25 per hour. So it is a 25 per hour if you wanted to use H plus 75. He needs to earn. He has to make some money, so he needs to earn at least $500. So 500 or more. How many hours does he need to work? Well, let's take that 75 to the other side. So 25x is greater than or equal to 425. And so x is greater than or equal to, I believe that's 17, but it's the end of the school day today, so let me just double check my math, 17 hours. So his next job needs to take him at least 17 hours or more for him to earn the money he needs. And look at that, that's it. You made it. The first 2 chapters are done. Hooray. I've got reviews up there for the test. The test needs to be taken on week 3, sometime before Sunday at midnight. Reach out to me with your questions. 2 chapters down, 6 to go. I don't even want to guess. I don't remember off the top of my head. Take care, everyone. Bye-bye.